Welcome to section 5.1, chapter 5. I'm going to be talking about polynomial functions in general, and in 5.1, quadratic functions. Polynomials are like quadratic functions with higher powers, x cubes and x to the fourth and x to the 100ths, etc. But here we are, we're going to start with a little introduction, some definitions, and something called vertex form. All right, so to begin, some mini little informal definitions. Let's say that we have some parabola, any parabola you could possibly desire. Something like this. This point right here, the very bottom of the parabola, is what's known as the vertex. All right, the vertex is the bottom, the top sometimes, right? If it's opening the other way, it's going to be where the maximum or the minimum is. We'll often use the letters HK when looking at the vertex, but the vertex is a point. Contrast that to the axis of symmetry. So the axis of symmetry is a vertical line. It's a vertical line, and this axis of symmetry is what it sounds like. It's the line that the parabola is symmetric about. Notice that this parabola is not an even function. It's not symmetric about this line, but it is symmetric about something. That's the axis of symmetry. And it's always going to be the form x is equal to h. Vertical line is always x equals a number. What is that x value? That x value is h. A couple other terms that we got going on over here. These are called the x-intercepts. You've seen that before. They're also called zeros. And I always forget whether I include the O or no, I know there's an O. I don't think there's an E though. I always get that confused. I might be spelling it wrong, but they're called the zeros. We'll find out later on when I do more problems. Those are important. And then we also have the Y-intercept, wherever that is. There's no fancy name for the Y-intercept. Okay, so these are kind of the big things that we talk about when we look at parabolas. So let's do a little experimentation, whatever English word you want to use, and try to use it correctly. Example 1. Find the vertex, the axis of symmetry. I should have mentioned that on our definitions page. Axis of symmetry, I'm going to be abbreviating A_o_s. Never writing axis of symmetry again, at least not in this video. Find the vertex, the axis of symmetry, the zeros, and the y-intercept for the following problems. And I'm going to have them on Desmos. If you want to have really good notes, you can pause the video, copy these functions down, or just copy the graph down. Okay? We need to find all this information. Let's kind of zoom in a little bit. So, the vertex. Vertex is either the top or the bottom. The vertex is going to be this point right here, 1, 1. All right, so let's write that down. Vertex is the point 1, 1. Vertex is a point. Always watch out for that. So it should always be answered as a point. The axis of symmetry, on the other hand, right? That's this vertical line, and it should always be answered as a vertical line. So where's the axis of symmetry here? It's the line that goes through the vertex. It always goes through the vertex. It's always this vertical line right here. This is the line x equals 1. So again, this is always the equation of a line. And notably, right, this value here and this value here are always the same. Because the axis of symmetry always goes through the vertex. We also want to look at the zeros. Where are the x-intercepts? Where do we cross the x-axis? We don't. There are no zeros here. None. If we tried to solve for them, we'd get complex numbers. But there are no real zeros. There are no x-intercepts. There is a y-intercept, though. There will always be a y-intercept. And that's about at 3, I think. Is it? Yep, it's literally at 3. Okay. So the y-intercept is the point 0, 3. There we go. We have answered the question. We've got all this stuff. Let's do some more. Part B. Going to be this next graph that I have prepared for you. Pause the video. Try to find the vertex, axis of symmetry, zeros, and y-intercept here. Well, the vertex is again the bottom of this graph. That's going to be at 0, -2. The axis of symmetry, I don't even need to look at the graph. As soon as I have the vertex, I know the axis of symmetry. It's the vertical line that goes through the vertex. This number and this number will always be the same. X equals 0. The x-intercepts, or the zeros, I do have to look at the graph for that, where it crosses the x-axis. At x equals -2 and +2. You can also express these as points. That's even better. But I'm not going to make you do that. This right here is really nice if you did it that way. You might get a smiley face while I'm grading your quiz. Anyway, last thing we need to do is the y-intercept. That's where it crosses the y-axis, which is right here, 0, -2. Ta-da! Now, notice the relationship between the axis of symmetry and the zeros. The x-intercepts are at -2 and +2. The axis of symmetry is smack dab between them. That's not a coincidence. That's how symmetry works, right? The zeros are here. The axis of symmetry is right smack dab between those x-intercepts. That is always going to be the case. Let's look at one more problem. And I think I want to change this one a little bit, I think. Because we haven't had any that are negative. Let's do this one. All right, so the vertex in this case is now at the top. It's the point 2, 3. Axis of symmetry, again, is going to be the line x equals 2. The intercepts, these are weird intercepts. They're irrational numbers, okay? But they're about at -0.449. And +4.449. So even though these are approximations, notice these are 2 is smack dab in the middle of them. And in fact, if we actually solved for these zeros, what we would get is -3, -6, +6, the square root of 6. I think this is 2 ± 6. Yep. 2 ± the square root of 6 is what these are. And you wouldn't have to do that, but we're going to comment on it real quick. Let's get the y-intercept real quick. It's at 0, 1. So that's our answer, but let's investigate. These zeros These are the two values of 2 plus or minus the square root of 6. The axis of symmetry is always in the middle of the zeros. The axis of symmetry is always right between, in the very middle, between the x-intercepts. So the x-intercepts were at 2 plus or minus the square root of 6. What's in the middle of 2 plus a number and 2 minus that number? This and this being 2 is no coincidence. These are always the same. And that's what we're going to use to find axes of symmetry when we don't have a graph. And that's a formula that we're going to develop here. Remember the x-intercepts, or the zeros. Well, that's when 0 is equal to that quadratic function. How do we solve this equation? When is a quadratic function equal to 0? Well, we have a little formula. There's a little song you may have heard. It goes something like x equals negative b plus or minus the square root b squared minus 4 times ac all over 2a. Please tell me that's a thing here in Washington. It's been a thing everywhere else I've lived. If it's not a thing, it's a thing now. Okay? This is where the zeros are. And just like before, to find the axis of symmetry, it's between the two zeros. And just like over here, what's between a number plus or minus the other number? This is where the axis of symmetry is, the stuff before the plus or minus. So the middle is going to be here. All right. And we could show why that's the midpoint using a little bit of math, but it'll take a little bit of time and I don't want to do that. The midpoint is x equals negative b over 2a. So you can memorize this formula, or you can just use this in your notes. Or if you can remember the quadratic formula, it's basically the same thing, right? Negative b over 2a is just a quadratic formula in the first half. It's the middle of the zeros. Because any graph, the axis of symmetry, is always going to be right between the zeros. Okay? So this is where the axis of symmetry is. And vertex is just the x-coordinate is at the axis of symmetry. And the y-coordinate is just the y value there. You just have to plug that x-coordinate into the y value. So these are very useful things for this section. So make a note of them. We're going to use them one final time in this video. And then I will unleash you upon the homework problems. Example 2. Determine. This video is titled Vertex Form, but we don't actually talk about vertex form in this video. That's a little strange. Determine whether there's a maximum or a minimum value. Find that value. And the axis of symmetry. And this problem is asking a lot. The vertex. Part A. 2x squared minus 4x plus 2 is our function. We haven't mentioned when there's a maximum and when there's a minimum. But we can answer that using what we know about function transformations. Right? Our toolkit function, let's do this in a different color. Our toolkit function x squared has a minimum. There's no maximum to this function, right? This function gets as big as it wants. The range of this function is 0 to infinity. if we do a vertical reflection, a reflection about the x-axis, that's negative x squared, that has a maximum. So all you do to find out whether something is a maximum or minimum is you look at the sign. You just look at the sign of the x squared term. All right, that's how we do it. X squared term is positive, looks like this. It's a minimum. X squared term is negative, looks like that. It's a maximum. So we have a positive, right? This right here is positive. Positive x squared term. So there's a negative. Oh, so there's a minimum. What is the minimum value? The minimum value always occurs at the vertex. The maximum value always occurs at the vertex. So we need to find the vertex. We need to find the vertex. All right. We need the vertex. How do we find the vertex? The vertex can be found this way. Let's find the x-coordinate first. That x-coordinate, negative b over 2a, is the axis of symmetry. And it's always smack dab between the zeros. So we're going to look at x equals negative b over 2a. And again, this uses the formulation for quadratic functions, ax squared plus bx plus c. That's what the b and c are, if you remember from your quadratic formula. So what is this equal to? B is negative 4. Be very careful to attach those negatives. So negative negative b is negative negative 4 divided by 2 times a. The negatives cancel each other out. We get positive 4 divided by positive 4. Oh, the axis of symmetry should just be 1. Great, that's our axis of symmetry. We needed to find that. Let's include that. So the vertex, right? If we find the axis of symmetry, the vertex is just going to be the y-coordinate on that axis. So let's find the y-coordinate here. When x is equal to positive 1, y is equal to 2 times 1 squared minus 4 times 1 plus 2. Type that into a calculator. You should get 2 minus 4 is negative 2 plus 2 is 0. So the vertex is the point 1, 0. Last thing is, what is our minimum value? We know there's a minimum. We set it in red up here. We know there's a minimum. The minimum value is 0. It's that y coordinate. All right. Let's see. We've done this. We've done that. Oh, we've done that. We're done with this problem. Let me know if you have any questions. Good luck. And we're going to do one more bonus problem in case you want it. If you want to see a part B, you can stay here. If you don't want to see a part B, that's no problem. Part B is going to be g of x equals negative 2x squared minus 12x minus 24. And again, our a value is negative here. A is negative 2. So we have this situation. There's going to be a maximum. It's going to open downwards. Let's find the axis of symmetry. That's going to be at x equals negative b over 2a. And again, a is negative 2. B is negative 12. So this becomes a positive 12 over a negative 4. That equals negative 3. This is our axis of symmetry. We need the y-coordinate to find the vertex. So plug this in. When the x-coordinate is -3, what's the y-coordinate? That's going to be -2 times -3 squared. Make sure you use parentheses here. That's very important. Minus 12 times -3 minus 24. I shouldn't do this in my head, but let's give it a shot. See if I have to correct this video. Is going to be +9 times -2 is -18. -18 plus 36 is +18. +18 minus 24 is -6. Let me know if this is wrong. I'll update the video, but it should be -6. So the vertex is -3, -6. Because again, once we found the axis of symmetry, the vertex is just that x value at the function value. The function's the y value. That's where that -6 comes from. So we said there was a maximum. Now we know the max value. The max value is that -6. This function never gets any higher than -6. In fact, plug in anything you want. You won't get anything bigger than -6. I guarantee it. Unless my -6 math in my head was wrong. All right, good luck. Let me know if you have any questions. And thus ends the video. For real this time.